Hello students, so today I'm going to be taking the place of Mr. Terra, and I'll be teaching you guys how to solve a problem related to bond energy. So first, let's start by reading the problem. So the energy required to separate the ions of magnesium hydroxide crystal is higher. So I'm going to make the question shorter. So basically what it's saying is that magnesium hydroxide has a higher latest energy than strontium hydroxide. As you guys can see here in the table, magnesium hydroxide has a 2,900 kilojoules per mole of latest energy, and strontium hydroxide is at 2,300 kilojoules per mole of latest energy. And the problem requires us to explain why is that using a periodic train and Coulomb's law. So let's erase the question. And I'll be drawing a periodic table. So the trend that you guys need to know to solve this problem is how the size of an element changes in the periodic table. So here we have a periodic table. It goes something like this. So the periodic trend for a radius of an element goes like this. So as you go from left to right on a period, the size of an element decreases. That's because you have the same amount of shells, but more electrons and more protons. That means that the shielding is the same, but the attraction is higher. So making the element have a smaller radius. And as you go up, start from up and going down. So as you go from down the group, the radius gets bigger. That's because you have more shells. So here, and the elements that right here have less shells than the one here. So making it have a higher radius. So that's the pure trend that you need to know to solve this problem. Now let's take a look at the Coulomb's law. So Coulomb's law has the formula F for force equals K. K is Coulomb's constant times Q1 and Q2. Q1 and Q2 are charges of the elements, of the ions that you're comparing. So in this case, we're comparing magnesium and hydroxide. And the charges are divided by the radius squared. So let's talk about the charges. So here we have a positive charge from magnesium and a negative charge from hydroxide. As you guys can see, we multiply them and we get negative, because positive times negative is negative. So that will give us a negative force. So that means they are attracting each other. And perhaps if we had a negative charge here instead of positive one, we know that negative times negative is positive, making the force positive. So we know that they are repelling each other. The same goes if we have both positive and positive. So positive times positive equals positive, leaving us with a positive force, meaning they are repelling each other. And you may ask, if we have a neutron charge, that would be 0, and then anything times 0 is 0, giving us a 0 force, meaning they are not repelling nor attracting. And the second important part of this problem is the radius. So as I said, in the periodic trend, as you go down the group, the element gets bigger. The radius gets bigger, and as you go from left to right on a period, it gets smaller. So magnesium is somewhere here, magnesium, and strontium is somewhere here. So as you can see, they are in the same group, but because strontium is below magnesium in the group, strontium has a higher radius. Okay, so this R signifies So this R signifies the distance between the element, between the two ions. So because Sr has a bigger radius than magnesium, the distance between magnesium and hydroxide is smaller than the distance between strontium and hydroxide. So making this value, if you are using strontium hydroxide, bigger than the value in magnesium hydroxide. So because we are dividing by a higher number, and because both of them have the same charges, we end up with a smaller force in strontium.